In the last example, we had a ball that was launched straight up into the air, and under the force of gravity, it decelerated at 10 meters per second every second. And when we graphed the velocity versus time, we could see that the area between the velocity graph and the horizontal time axis gave us the net change in the displacement of the ball. Okay, and we had some positive area and we had negative area, and the positive area uh, was how far the ball traveled up, and the negative area was how far the ball came down. All right, so in that example, we had some context around the meaning of that positive and negative area. But in general, if we're integrating a function and finding the area above the x-axis or the horizontal axis is counted positively, right? It's counted as positive area, and area below the horizontal axis between the graph of the function and the horizontal axis is counted as negative area. All right, so in this example, we're given several graphs of f of x, and we're asked to decide whether the integral from 0 to 5 of this function f of x is positive, negative, or approximately 0. Okay, so remember that the integral is just giving us the area between the graph of the function and the horizontal axis. Okay, so you can see here, this area right here, that's the area between the graph of the function and the horizontal axis. That is positive area, right? Positive. And then if we integrate all the way to 5, you can see all of this area is negative. Whoops. Is negative area, right? So this is negative area. All right. So the net change, right? The net area here, we have a little bit of positive, but we have a whole lot more negative area. So when we find the net area, it's going to be negative. Negative. All right. All right, so let's take a look at the next function. We're integrating from 0 to 5. So here we have a little bit of, this is negative area. Negative area. Okay. And this area here, right? This area is positive area, right? This area is positive. Now, it looks like we have more positive area than negative area, so the net area is going to be positive. Okay, so that means that the integral, when we integrate from 0 to 5, is going to be positive because we have more positive area than negative area. All right, now in this last function, we've got positive area here. Whoops. Let's see, positive area here, right? This is positive area. And, oops. That's positive area. And then down here we have negative area, right? So this is negative area. Now when I compare those areas, it appears that they're about the same size, right? So the negative area is going to cancel out the positive area, and the net area is going to be 0, and so that integral is going to be about 0, it appears from that graph. All right, I'll see you in the next example.